Hi, I'm Sophia. I'm a rising senior majoring in nutrition and biology with a chemistry minor. I've been a ULA for 3 semesters, and every time I do it, I'm reminded just how much I love teaching and helping students work through problems and gain confidence in subjects that are often seen as kind of scary and intimidating, and helping them realize that chemistry is both achievable and can be cool and satisfying. I love seeing those aha moments and finding creative ways to explain problems to students, especially if it's a problem I myself remember struggling with, and when I'm able to pinpoint exactly where that struggle is because I remember where my struggle was, that's always really cool as well. And I'd love to be a ULA again. So, to better aid in student understanding, especially for 262, I would encourage students to not memorize their way through mechanisms or problems, but to think deeply about it and to pull from information that they already have. So, for example, when I was a ULA for 262 last semester, I think a lot of the questions I asked students were things like, well, what functional groups do you see? What can you tell me about this leaving group? What's the pKa of this? Is this aromatic? Which way is this reaction going to be favored? I think a lot of times students have all the right tools, they've got all that prior knowledge, but they're just seeing it applied in a different way, and then they get scared and uncomfortable. But it's really your job as an LA to just help them pull from the information they already know and apply it in the right way. So now I am going to do a problem. This is one of my favorite reactions from 262, Claisen condensation. So the question asks, how would the compound be prepared by Claisen condensation without LDA? So this is our product, and the first thing I might ask the student is, well, what does LDA do, and why did they say that we're not using LDA in this context? What does that sort of imply? And hopefully this would get them thinking about the fact that when we use LDA, that's going to completely form enolate, and we're not going to have any of our ester left over to serve as an electrophile. On the other hand, when we use a weaker base, some of it is going to form enolate and some of it is going to remain as an electrophile. So since we're not using LDA, this probably implies that our ester is going to be the same. We're not doing any sort of crossed Claisen or anything. Some of our ester is going to form enolate and some of it is going to stay. But looking at this product, I'm seeing a 5-membered ring, and I'm not seeing an obvious place where we could just split this and get 2 equal esters. So I might ask them, okay, well, what does it imply? What do you think about when you see a 5 or 6-membered ring? And hopefully they would say intramolecular reaction, which would be great. That's right. When we see a 5 or 6-membered ring, we know that's highly favorable, and we might want to see if this is an intramolecular reaction that's going on. And from there, we can just work backwards. We know that with Claisen, one of our esters is just going to remain and not pop off. So that gives us a good clue as to what our reactant is going to look like. We're going to have an ester on both sides that is going to look like this. Has to be the same on both sides because either of our alpha carbons could be deprotonated to form enolate. So we need to make sure that we're getting the same product either way, whichever way we attack. And then I would ask them, okay, what base are we using to form enolate? We know it's not LDA, and I would make sure to ask them, why is it important that we're using ethoxide? Really looking for the answer that we're trying to avoid trans-esterification, right? So we need these to match. And then lastly, I would ask them, okay, why are we doing an acid workup? Looking for the answer that once we've formed our beta keto ester, this is highly acidic. Remember, this is a pKa of about 11. So that's going to just automatically be deprotonated. This is our irreversible step that's really driving this reaction forward, and we've got to follow it up with an acid workup. So this problem has a lot of stuff going on. It's really important for students to not get freaked out and remember that they have all the tools to do this, and they just, have to have a lot of practice to recognize intramolecular reactions, know to use ethoxide to avoid transesterification, and remember with these equations that acid workup is super important. And yeah, so thank you for considering me as an LA.